Good morning or good evening, wherever you are. Last time we were fighting a bit with string concatenation, and I am trying to do everything online, live, but I had to Google it because I was pretty sure last time that we had a function to do this for us, and it turns out there are. So there is a solution. So we're gonna find that one and try to use it. We were concatenating the current path, which we got from this self exit dir path, and then we wanted to add it the argument that we had from the command line. I have no clue what the command is called. Yeah, it was called something with path and join. So I guess that we can probably find it here in the seg std. So let's see if we can find something with path. There was a lot with path. Join? Path join. It's right there. Path join. So not much description, but okay. Path join. Not really sure if that is the one. I'm pretty sure it was called path.join or something, but let's see, path. It's nothing's just called path. Join naively combines a series of paths with the native path separator, allocated memory for the result, which must be freed by the caller. So guess that might be the one. So let's take, where did we have the final one? Full path. The path buffer. We have it in the path buffer. But let's see if we can do it in a different way instead of doing this. Let's see if we can do std path file system path join, and then it needs an allocator, and it needs the parts. And the first one would be the path itself. What we got here, current path. And then what we got from the input, the argument, it's actually right there. And then we need an allocator. Path allocator. Or did we already call something the path allocator? I think we did. Yeah. Page allocator. We can call it full path. Full path allocator. So we're just gonna, but it only needs the allocator, it doesn't need the buffer. So can we just do it like that? That would be it. And then we would have, what does it return? It returns an empty, an error or an array of U8s. But there's no errors defined, so does it just throw something? Because no error is defined here. And here neither, so that's kind of weird. But let's see if they are not actually doing the same thing that we did. Yeah, it does look like it. And separator, step, allocation, back. And see here, we can try to set full path equal and just write out the full path. Like this. Let's see what happens. It doesn't want to build. It's funny, I see a pattern here. Feels like it's always something's wrong. Inferred array length is specified with an underscore. What does that mean? And once again, it would be wonderful if somebody in chat actually knew. I could just say you just need to add an ampersand or an underscore or something. Const u8 does not support array initialization syntax. Yeah, to save everybody some time, I'm just gonna Google this. I wanted to have this kind of pure learning, just looking at the manual and hopefully everything would make sense. But we do need some other information I learned by examples. It makes a lot more sense to my brain than just the raw specific details here. If it says join, it does says const u8. It's I need to see how it's used to make sense to me. And once again, a web page without the string I actually looking for. Shorthand for the path without the allocator noise. Maybe it's the wrong one, because it does look like maybe it is an ampersand. So we need to give it the address of this. Just feels wrong having to do this. Oh, this. Yeah. Pretty sure that's not a solution. Now what is that? But the argument at location. Didn't we do that already? A lot of silence here and thinking. Because here we do have the argument, but it's in this. It wants a const u8, but we found this and I can't remember what that actually means compared to a simple array. Didn't I make a cheat sheet? Yeah, but that doesn't include that one. Would have been nice. So are we already at a point where we would like to ask an AI? I don't want to. I want my brain to figure this out. But let's see. Seg.path.join. See if we have something. It has this one. Pointed to paths. What is this? Sorry. What do we have here? I haven't seen this, and I haven't even seen a definition of string as const u8. But what does this mean? It should be so easy. Once again, it's just in the details. Because this is what we're actually trying to do, right? Of course, we need to add a try to this one. Or a catch. But that shouldn't change the issue with the formatting of this. But it still wants a pointer to the paths. So I guess that this one needs to stay. The only thing that's the problem now is the conversion of this from this. How do I do that? I can't just do a just cast, or not cast, coerce it into being this, right? No, of course not. I'm sorry, but it's part of the learning process. I need some information I can't get anywhere else. So we are gonna ask DuckDuckGo's AI. U8 is a slice that can have a dynamic length. I like to call these arrays and not signifies a zero-length array type, which causes the type conflict. Use dynamic sizing with std.mem. And then it doesn't suggest anything with mem. That's just that's just weird. Again, AI, you can't trust it really. Because here we're just assigning it to a value and then using that value. This wouldn't make any sense, would it? Why would that change anything? If that changed anything, then it would be really weird. Yeah, it still says, yeah, because it hasn't changed anything. But we used the std.mem yesterday or last time to do some conversion from the zero, what was it called? Zero terminated, null terminated. Yeah, we used this to get the length of it. So can we do the thing that we did yesterday? Remove all of this and just say all we want from this one is a 0.digit slice of this, and remove the s. So we're saying, yeah, we want this one, but we only want the slice from 0 to the file length. We could. So again, it didn't solve the problem, but it pointed us in another direction. And I remembered using this one as it suggested to get the length, and then we can convert it. So let's see. No. A new error. But actually not at that location. Just to be able to see where it actually writes out this one. There it is. The full path. So that's good. That's really good. So progress. Small steps, but still it's progress. So instead of doing this myself, I can just remove that. So now we have access to the full path, which is nice. And then we want to open that file for reading. Buffered output. We're not going to do any writing. We want to open the file. And the absolute path is now our full path. And we want to open it for reading. I'm not sure what we're using this for. We now have the full path to the file. We're doing a page allocator, buffered output. So we making an allocator. What are we using this for? We're making a writer to the standard output. Oh, it's our old print to console, but we decided just to use the debug print right now. So I guess that we can just remove this. I know that it's being used later on. So we can just remove this one. Bytes red. Okay, fair enough. We still have the std debug. What was it? std debug print? At times this autocomplete or yeah, code completion is just weird. Buffer content, buffered. Yes. Let's see if it still compiles. It doesn't. Now what? Consider omitting try. Where are we at? Expected union found void. Line 115. Oh, added the try. Remove that one. Yes. Cool. Then let's get back to this one. Open flag read only. A bit of error handling. Trying to open. Close it on defer when we exit the block. While I remember, we had this other project where we wanted to return different default values depending on an error. Turns out that you can do it by naming the block, then you can return from the block. You can return a value from the block. So you can do it, but that's just a note for later. Bytes red. So we are making an allocator of 2 kilobytes and we want to read. Yeah, actually, sorry about that one. Need some water. If we just make an allocator and we take 3 bytes. Yeah, not very efficient. But we read, yeah, if we read 3 bytes at a time, we would never read more than at most 3 bytes that wasn't there in the file. So we can, yeah, it doesn't really matter, but I would really like the buffer to be kind of divisible by 3 as our encoding to Base64 that we looked at yesterday. Base64, Wikipedia, we could see that 3 bytes maps into 4 Base64 elements or characters. Yeah. But for now, let's start by reading all of it and just limiting ourselves to files that are only 2 kilobytes long. Doesn't really matter for now. It's the algorithm that's interesting right now. So we are opening the file, reading the file, and here we have how many files were read into that buffer, the file buffer. So we can do a what happens if we asked it to read the file but the buffer is too small? What error do we get? File not found. What? File not found. Oh, it's from the executable, not from where I executed. That's not optimal. Okay. Then let's move the Oh, I didn't even copy the test file. Fair enough. Sig out, bin, yeah. Then it shouldn't give us any errors, right? Oh. Buffer content test, yes. And then we get some weird errors here, segmentation error in the allocator. But why? Do we have an allocator that we are not closing down? Didn't we do that for the one we did for the full path? Yes, we did. Free this one? Oh, path buffer. Oh. How are we gonna free this one? Because there's no buffer allocated. Can we just do like this? No. But when is that allocator freed? Yeah, because this join, we are only giving it this one. So should that be free this one? That would be pointed to. Huh. That was a new one. So I think that's the idea that I can't remember the name of the creator of SIG, but his idea is that you give the different functions an allocator as a parameter, and it handles the allocation itself. But if it does, we will need to still be able to free that part at a later time. So when we have used it, that function and an allocation has been done. I'm a bit confused if you can use the same allocator to do multiple allocations. Again, something we need to figure out or look into. Still, I had in a previous test, I would like to see if the allocation at the memory, the memory allocated, if that was the same. I can't even remember. I think it was actually for the path that we had earlier, but it doesn't matter. We now have the full path. We have this, so we do deallocate this memory as well, even though we didn't allocate the memory itself. This function did. Again, it's very readable. Create an allocator, give it to a function that will use that allocator, free that memory that was allocated. It makes it really clear. And here we're saying if an error happens, throw it here. So all good, all good. And if we only have a buffer of the size 4 and we read, we don't get an error. We just only get information. How do we read until we get to the end of file then? Because we can start out by doing this. Then we're sure that we only get 3 bytes at most. And we can say if bytes read are less than 3, then we only have part of the buffer filled, and that is the file buffer. I would really much like to make a for loop that says from bytes read up until 3 use size, and we take the file buffer. Oops. This would just be an index or IDX. I like index or I. And then we take so if we only read 1 byte, we are already at location 1. If we read 0 bytes, it's at 0. And we should reset all of them. So yeah, I would set those to, what would I set it to? It's a nothing. So I guess that would just be zeros. And I can just read it as zeros. That's kind of weird that they're using equal. Equal isn't a part of this. I actually thought it was. Because value 0. Value 0 is actually a character. So I can't just set it to 0, because then that would be encoded to A's. So no matter what I set the last 2 bytes to or whatever, it doesn't work that way. So, man. So we'll do it the other way around. We're going to take from index 0 to the number of read bytes. And then we can, in here, we can say if bytes read are less than current index. No, it will never be that. if we say it matches up with 3 bytes. We have read the buffer is full. Let's take that scenario first. We need to take the first data in the file buffer. We have that here. We don't even need a for loop for this because we need to do different things for each of these. But we need a place to store this. So we also need a new allocator and buffer. And we need to remember to delete it after the fact. Allocator for Base64 output. Allocator, page allocator. Yeah, let's just go with it. I know there are different allocators with different usages, but for now, let's just use a page allocator. I know it's totally overkill, as one page, as I understand it, is typically 4 kilobytes, and we only need 3 bytes. So yeah, huge overhead. Buffer, Base64. Base64 output, and we're gonna deallocate that. But we're gonna into the first one, we're gonna take what's in the first file buffer and it with, can we do 1, 2, 3, 4, 5, 6 binary and like this. I don't know if it can handle this allocation or not allocation, definition, but I think it can, and this should be an index into our Base64 char. Yeah, and that doesn't exist yet. But we can add it somewhere up here. That's a comp time constant equals an array. I can't remember how long it is, and it's a U8, and it's just like this. And then I'm gonna grab it from here, I think. Maybe that's, no, that's a bad formatted. Then we need to. Don't we have a list of the Base64 characters? Yeah, thank you, but come on, please. First the uppercase letters, then the lowercase. So we can just take these. And last 2 special characters here. And we still compile? No, we don't. Expected U8. Yeah. No. Inferred length specified with an underscore. Yeah, but I just did that. And you complained about it. So why are you complaining about it? Expected type U8. Yeah. Found pointed. Come on. Again, it should be so simple, and I forget about how to define the simplest of things. Should it set it equal to this? No, right? That wouldn't make sense. Where are my address bar? Why is that vanished? Weird. I must have clicked some weird shortcut. Arrays. Hopefully not. Again, individual characters, but yeah. Why can't you just... That seems... Am I completely forgotten something very basic? U8 string. But it didn't want to do that. Oh, like this. So I could just have done that. Yeah, maybe. No. Yeah, but I just want the U8. We do. What about this? Why can't I tell it that I just want to unable to infer array size? But this should be a time const. Yeah, literals and compile time. Exactly. I pointed to an array byte where the last byte is guaranteed to be 0. No. We want the second one where we have a const. What's the difference? What am I... Isn't that exactly what I was doing? Is it just because of this that it needs to be a const? No? Yes? Yes, 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 perfect. So it didn't understand this one, cannot represent integer value. Why not? Type U8 cannot represent integer value, but that should only be 8 bytes. Or did I add too much? Should be 8 characters, right? 5, 6, 7, 8. Yeah, that's just 8. Ah, sighing. Because this is what I want to do here. Why does it... Whoa. Oh, X. It should be a B, right? Yes. Perfect. So as I understand right now, we are doing a Base64. Let's see here. So what we are doing right now, we are taking the first byte, but we are ending it with 1111100, 1111100, meaning that we are only getting this. But if that's the high bytes, then we need to shift it as well. Are we on what's it called, big Iridian or small Iridian? I can't remember what's it called. It's how the bytes are in which direction the bytes are read. Do we have 1, 2, 4, 6, 8 this way, or do we have 1, 2, 6, 4, 8 that way? That's probably easy to figure out. This is 255, so this one is the lower bytes. Oh my god. Okay, then we need to byte shift this to, if that is, I don't know if it, in other languages, this should shift it by 2 bytes. So we end it with this to get these bytes, and then we shift them down so we can use them for indexing. So that should be well and good. Then we need what should be in the next one. And the next one should contain these bytes. So that's a little bit of one from one and one from the other. So what is the easiest way to do this? I guess that we need the second one and only the upper bytes. 1, 2, 3, 4, 0, 0. And then we're going to shift them 4, but then we need to add these 2 bytes. And then we're going to add and we have to remember, of course, we're reading the second byte. And then we're going to add the first one and it with the opposite of what we did before. 1, 2, 3, 4, 5, 6. And we're going to shift it the other way. And we're going to shift it 4 bytes, 4 bits. So we're shifting this. So we have these 4, but shifted the other way. So that looks good. And then we need the last one, where we're reading, what do we need from that one? We need the, let's see. No, it's 4. Of course, the output will be 4 characters. So we are only at this one. So that's the lower part. If we start with the upper part of the third one, or should we start with the lower part? Yeah, let's do that. We're going to take the lower part of the first one. So again, kind of the same as we did before. This time we are just not, yeah, we need to shift them to the left. So we can make room for the last ones at the bottom. Oh, am I doing something completely wrong here? My brain just went poof. We're reading the file buffer, ending it with this one. So we have these, and we're going to shift them to get them to the bottom. But we should do that before we take the index. So just to make completely sure, this is what we want to do. If we ever try to index outside this one, we've made a mistake. So I think that this is also wrong. Again, it would be nice to have somebody yelling in the in the chat telling me that I'm doing stupid stuff. So this takes these 4 bytes, shifting them down, and then putting the next one on top. So we have this. Yes, that looks more correct. And maybe I'm not sure about the order of execution of bit shifting and anding, so maybe it will give some issues as well. But let's take that when we get to it. And there. So let's look at this one again. What we need are these bytes. So we need some of the ones from index 1. We need the lower 4. Yes. Where do we need to locate those? We need them shifted to left. We did that. And then we need the higher 2 bytes from location 2. And we need to shift those all the way down to this. So 1, 2, 3, 4, 5, 6. So we're going to shift those the other way, 6 bytes. And then for the last one, it's all located in the last one. And it's just placed the correct way. So let's take a look at that one. Find location 2 and the last 6 bits. So that should be it. And maybe we're just able to do this Base64 content. Above content, Base64. Nope. What are you now on about? Unsigned 3-bit int cannot represent all possible unsigned 8-bit values. What? What? 126. So this one might be the issue, but as I said, maybe we need to do this as well, and this. Come on, I didn't ask you to do that one. Yeah. VGV TES. So if we take this copy and we go back, look at the decoder and decode, we actually get the right values. We do get TES, and that is exactly what we wanted to encode. So this was right. So perfect. Now to the edge cases of it not matching the 3 elements. So yeah, my brain isn't working fully this morning, but again, we are close to an hour and I still have work to do. So maybe this is a good place to stop for today. We did actually get the first 3 bytes Base64 encoded and verified that it actually worked. So that is perfect. We found out that we can use this standard library function called path.join with a little bit of issues with this one. I still have a hard time understanding this multiply colon 0 notation. This one, this to me is unreadable. It's an array, yes, of all the arguments. Get that. That I understand. But that it is unknown length but 0 terminated. I think that's what it means, right? But why use the multiplication symbol instead of the underscore, as we use the underscore if we don't know the length of it? Who cares? Who cares? Just something I need to get used to. Again, I try not to learn anything about SIG outside the stream, so it will be a full view of how long it actually takes for an average person, I guess, to learn a new programming language. I've been programming for, almost 40 years in different languages on different platforms, but still a new language and a new programming, what's it called? I've been used to object-oriented programming, and this is not object-oriented at all. I think you can do some, the closest thing you get to an object in SIG is struct. Damn, that was hidden far away in my memory. Structs, of course, because you can add data and functions and so on to structs as well. But I don't think there's anything like inheritance and so on. But yeah, that was it for today. And as always, I will upload this to YouTube and all comments are welcome. Please point out where I'm doing stupid stuff if you want to, or just laugh at my ignorance. Everything is welcome. So until next time, have fun and enjoy life, right?